Welcome to the deep dive. Today we're zeroing in on a fundamental design pattern. It comes up time again in serious software architecture discussions, and, well, it's a must-know if you're aiming for senior-level roles and prepping for those technical interviews. We're going to really explore the Memento pattern. Think about those times you've maybe wrestled with implementing a robust undo feature or needed to, reliably revert a complex system back to how it was before.
Yeah,
This pattern, it provides the architectural blueprint for exactly that.
exactly. And, for anyone gearing up for those senior software engineering interviews, understanding Memento goes way beyond just like memorizing a definition. It really shows you've got a solid grasp of core design principles, encapsulation, separation of concerns, things like that.
Right.
Interviewers definitely look for that kind of thinking. It's a key indicator of experience and architectural maturity.
Absolutely. So our mission today in this deep dive is to truly get the Memento pattern from the ground up. We'll dissect its core purpose, look at the key players involved, and examine both the benefits and, the potential drawbacks too.
Right, the trade-offs.
Yeah. By the end, you should have a really clear understanding of what it is, but also like when and how to use it effectively, especially when you're discussing it in an interview context.
Okay, so let's kick off with the main problem Memento solves. Imagine you've got an object, right? It holds some critical internal state. Maybe it's the current config of a system or the progress of some long calculation.
Hmm.
The challenge is, how do you save that state at a point in time so you can restore it later without breaking encapsulation? That's the key. You need to keep its insides hidden.
It's like trying to save the setup of delicate instruments in a complex machine, right?
Yeah.
You want to capture their exact positions, but you wouldn't take the whole machine apart to document everything. That would ruin the setup.
Exactly. You destroy the very thing you're trying to save.
So Memento gives us a way to take a sort of self-contained snapshot.
Precisely. And that brings us to the main players in this pattern. First, you have the originator. That's the object whose state we need to save and restore. It holds the important info, and crucially, it knows how to create a snapshot of its state and how to use a snapshot to go back.
Okay, the originator. Got it. Then there's the Memento itself.
Right, the Memento object actually holds the saved snapshot. And a really critical point here is that it's meant to be opaque.
Opaque, meaning?
Meaning its internal structure, the data inside, isn't meant to be accessed by anyone except the originator that created it. Think of it like a sealed time capsule.
Okay, a sealed capsule. I like that. And the third piece.
That's the caretaker. The caretaker's job is basically to hold on to these mementos. It can ask the originator for a memento, hey, give me a snapshot, and later it gives a memento back to the originator for a restore.
But and this sounds important.
Yeah.
The caretakers can't look inside the Memento.
Exactly. That's a core design principle. The caretaker just holds it, like for safekeeping. It doesn't know or care what's inside.
Okay, so initially, you could imagine maybe the originator just handles its own mementos directly, creates them, keeps track of them.
You could picture a direct line. Originator creates memento, originator manages memento. Simple enough, maybe.
But for better organization and that encapsulation thing you mentioned, we often bring in the caretaker.
Right. Introducing the caretaker makes the relationship more indirect. The originator still creates the memento, takes the snapshot, but the caretaker steps in to actually manage the storage and retrieval of those snapshots.
So the originator hands off the memento.
Exactly. Hands it off to the caretaker. Then, when you need to restore, the caretaker finds the right memento and gives it back to the originator. This separation of concerns is really key.
Why is that separation so important?
Well, it keeps the originator focused on its main job, its business logic. It doesn't have to worry about managing a history of states. That's the caretaker's problem. It follows the single responsibility principle. Okay. Plus, it makes the system more flexible. You could change how the caretaker stores the mementos, maybe in memory, maybe on disk, maybe in a database, without touching the originator at all.
That makes sense, decoupling things.
Yeah.
But you also mentioned sometimes the design might move the other way, towards a more direct relationship.
Yeah, that's possible too. Maybe the initial setup was already a bit indirect, perhaps involving some external service. In that case, simplifying things might mean bringing the memento creation and management closer to the originator, maybe even integrating the caretaker's role, partly or fully, into the originator.
So it's not a rigid rule, always add a caretaker. It's about strategically managing state snapshots while respecting encapsulation.
Precisely. It's about finding the right balance for your specific needs.
Okay, let's try to make this structure more concrete. How does it look in, say, a UML diagram?
Good idea. In a typical UML representation, the originator class would have some internal attribute, let's call it state. That's the data we want to save. Then it'll have a key method, maybe create memento. This method creates a new memento object and puts a copy of the originator's current state into it. It returns that memento.
So the originator defines what needs saving.
Exactly. And then, crucially, the originator also has a setMemento m method. That's how it restores itself.
How does setMemento work?
Internally, when setMemento is called with a memento object, the originator pulls the saved state out of that memento and uses it to overwrite its own current state.
Okay. And the memento class itself.
Its main job is just to hold that saved state. It might have methods like getState and setState, but, and this is important, these are generally meant only for the originator to use. Keeps it opaque to everyone else.
Right, that opacity again.
Yeah.
And the caretaker in UML.
The caretaker is shown having a connection and association with the memento. Its main role is just holding on to these mementos, maybe in a list or a stack. Critically, you won't see methods on the caretaker for accessing the memento's internal state.
So if I'm in an interview talking about handling undo, I could say the caretaker manages the undo points without the main object needing to track that history itself.
That's a perfect way to put it. It holds the history, the undo points, without needing to know the details.
Okay, so the flow is caretaker asks originator for a memento, originator creates it, fills it with state, caretaker stores it. Later, caretaker gives a memento back to originator. Originator uses setMemento to restore.
You've got it. And throughout that whole process, the originator's internal details stay hidden. Encapsulation is maintained.
Let's trace that sequence again, just to be super clear. Saving state.
Okay, the caretaker decides it's time to save. It calls create memento on the originator.
The originator then makes a new memento instance.
Right. And inside create memento, it copies its current internal state into that new memento object, maybe using an internal set state on the memento.
Then the create memento method finishes and returns the filled memento back to the caretaker.
Correct. The caretaker now has the snapshot.
Now, for restoring.
The caretaker decides which previous state to restore to. It digs out the corresponding memento it's been holding.
Yeah.
Then it calls setMemento on the originator, passing in that chosen memento.
And inside that method, the originator uses something like getState on the memento to retrieve the saved state.
And uses that retrieve state to reset its own internal state. Done. Back to the past.
And the caretaker was just the messenger, basically, holding the package but not opening it.
Exactly. It never needed to know the specifics of the state.
This really clicks when you think about real-world stuff, like undo in a text editor. You type, make a mistake. Ctrl plus Z.
Perfect example. Each significant change, or maybe every few changes, could trigger creating a memento. The caretaker, maybe an undo manager component, keeps a stack of these mementos. Undo pops one off the stack and tells the originator, the document model, to restore itself using that memento.
Or like saving your progress in a video game, hitting that save game button.
Absolutely. You're deep in a level, things are complex, you save. That's the caretaker asking the master game object, the originator, for a game memento. The caretaker stores it, maybe writes it to a file.
And if you mess up later, you load the save game. The caretaker retrieves that memento from the file and tells the master game object to restore. It makes so much sense now.
It really does. And it highlights those two core goals again. Save the important state and do it without breaking encapsulation.
Okay, so let's summarize the pros. What are the big wins with Memento?
Well, first, it helps keep the originator clean and focused. Cohesion, right. State management history is handled elsewhere. Second, that strong encapsulation we keep mentioning. The originator's internals are protected.
And third,
it provides a pretty straightforward way to implement recovery features. Underrato, save points.
Yeah.
It's a well-understood pattern for that.
But it's not perfect. What are the downsides, the trade-offs?
The big one is often performance and resource usage, if the originator state is huge.
Like tons of data.
Yeah, lots of data, complex object structures. Creating that memento means copying all that state. That can take time and memory.
And restoring could be slow too, presumably.
It could be, yes. Especially if you're restoring very frequently or the state is massive, you have to consider that impact.
You also mentioned Java serialization earlier.
Right. In Java, sometimes people use serialization as a shortcut to grab the state. It can work, but serialization itself has overhead. It can be slow, the serialized form can be bulky, and it can be brittle if the class structure changes later. It's not always the best approach, even if it seems easy initially.
So something to use with caution. Let's go back to that game example. We have a game memento class. just holding the saved game state.
Yep. And the master game object, the originator, would have the live game state. It would have get current state to create and return a game memento.
And restore state, game memento save state, to take a memento and update its own game state.
Correct. And then some client object acts as the caretaker. On save, it calls get current state and stores the result. On load, it retrieves a stored memento and calls restore state.
And again, crucially, that client caretaker never looks inside the game memento directly.
Never. That's the discipline the pattern enforces.
Okay, beyond basic undo and save games, where else does this pop up? You mentioned a graphical editor.
Yeah, think about constraint solving in an editor. You move an object, and lots of other connected things might need to adjust based on rules or constraints.
Like keeping lines connected to boxes when you move the box.
Exactly. If you undo that move, you don't just move the box back. You need to restore the entire state of the constraint system, which objects were connected, what the constraints were. The constraint solver could be the originator, and a solver state memento could capture all that complexity.
Wow, okay. That's much more intricate. You also mentioned narrow and wide interfaces for the memento.
Right. Ideally, the memento shows a narrow interface to the caretaker, basically. No methods to get or set the state, just an opaque handle. But it needs a wide interface for the originator, so the originator can get and set the state during saving and restoring.
How do you achieve that?
Well, some languages help. C++A's, for instance, has friend classes. You could declare the originator as a friend of the memento, giving it special access to private members or methods that aren't available to anyone else, like the caretaker. Other languages might use interface segregation or specific access modifiers to achieve a similar effect.
Interesting. And the idea of storing incremental changes instead of the whole state.
Yeah, that's useful sometimes. Think about a command pattern for Unduredo. Each command knows how to do something and how to undo it. The memento might just store the information needed for the undo part of that specific command rather than the whole application state.
So potentially much smaller mementos.
Could be, yeah. Especially if the overall state is large, but each command only changes a small part. Save space. The downside is, restoring to a state from way back might involve applying a whole sequence of these incremental undo steps, which could be more complex than just loading one big state snapshot. Trade-offs again.
It's cool how versatile it is. You mentioned uses in Unidraw and Dylan.
Yeah, Unidraw for graphical editors definitely uses it. And in Dylan's collection iteration, the state object you get when iterating basically acts like a memento. It lets you pause and resume iteration or even have multiple independent iterations over the same collection without exposing how the collection works internally.
And that QOCA toolkit.
Right, the constraint solver. It stores incremental solution information in mementos, helps it backtrack efficiently when searching for solutions.
Okay, wrapping this up for someone prepping for an interview. Key takeaways.
Know the intent. Capture state externally without breaking encapsulation for later restoration. Know the players. Originator, memento, caretaker, and their roles.
Be able to explain the flow. Create, store, retrieve, restore.
Yes. And articulate the benefits. Encapsulation, simpler originator, recovery mechanisms.
But also the drawbacks.
Definitely. Be ready to discuss performance costs, time, memory, especially with large state. Mention the complexity of managing the memento history, potentially. Show you understand the trade-offs.
So demonstrating that balanced view is important.
Absolutely.
I know.
It shows maturity. Discussing trade-offs is often more impressive than just reciting definitions.
This has been incredibly helpful. It really clarifies memento as a core pattern for managing state robustly.
It really is. And being able to talk about it fluently with examples, discussing the pros and cons, that's a strong signal in a senior level interview. It shows you're thinking architecturally.
Well, thanks so much for this deep dive. And for everyone listening, especially those prepping for interviews, here's a thought to chew on. Think about a complex system you know well. Where could Memento have potentially helped? Could it have simplified state management or maybe added a much-needed undo feature? What would the main challenges have been in implementing it there?
Good question. Mulling over real-world applications like that really solidifies the understanding.
Definitely. It takes it from theory to practice. Thanks again.